This video is for the Unit 1, Skill 1 Formative Assessment. At Level 2, we are being asked to find the derivative of the given function. So I will immediately start by using my function notation. I'll write out what f of x plus h is equal to. Of course, f of x is just the original function. And then I'll do the necessary algebra in order to start using the actual definition. So I'm going to get the following now. Negative 2 times x squared plus 2xh plus h squared minus 4 times x plus h plus 1. And then again, from f of x, I still just have the same negative 2x squared minus 4x plus 1. And now I'm going to go ahead and I'm going to subtract these two expressions. So I'm going to look for those common terms. Here I have a negative 2x squared, which will cancel with positive 2x squared from the negative negative. I have negative 4x here and positive 4x on the bottom, positive 1 and negative 1 there, leaving me with the following now. Negative 4xh minus 2h squared minus 4h, all of that divided by h. And I notice, again, each term has an h in it. So I'm now left with negative 4x minus 2h minus 4. Well, I want to remember from the very beginning of this problem that we were looking at this as the limit as h approaches 0. As h approaches 0, that term will go to 0. Final answer, negative 4x minus 4. Next, I'm going to move to the level 3 question. At level 3, I have the following. Gives me a function defined by the piecewise expressions. It wants a and b to make f both continuous and differentiable. As we learned in class, differentiability implies continuity. It also tells us that we can cheat a little bit. We don't have to use those formal limit definitions. So I'm going to choose to use the power rule in this to make my life a little bit easier. First, I'm going to address the continuity piece as defined by the notation c sub 0. In order for this to be continuous, then the piece on the left, about 1, which will be 3 minus 1 or 2, has to be equal to the piece on the right of 1, which will be a times 1 squared, or a, plus b times 1, or b. Second, I'm going to address the differentiability piece. In order for this function to be differentiable about 1, then the derivative from the left of 1, well, the derivative with my power rule of 3 minus x is just negative 1, has to be equal to the derivative from the right, which again, via my power rule, is 2ax, so about 1, that's 2a, plus b. I now have the following system of equations that I can solve. If I subtract these equations from each other, the b's cancel and I have 3 equals negative a. So a equals negative 3. And if a equals negative 3, I can go back into this equation and say that if a equals negative 3, then b must be equal to 5. And there's my answer. Finally, we will do the level 4. The level 4 gives us the following instructions. Given that f is continuous over this interval, use the table to sketch a possible graph of f. So here's where we're going to connect some work from physics last year, if you remember that. So f is the function, and f prime of x is the derivative, which we now know means slope. So from -10 to -4, what it tells us is that both our functional values are positive and our slope is positive. So from -10 to -4, we must be doing something like this. Now that's not the only way I could do that, but it is one way that we could do it. I then realize at -4 I want to have a functional value of +5. So I'm actually going to erase that and realize at -4 I should have a functional value of 5, so I can still have a positive and increasing function by making it look like that. And let me get a little more slope over here. Again, that's not the only way to do it, but it is a way to do it. I now have that the derivative doesn't exist at -4. That means I either have to have a break, a corner, or a cusp. So let's see what this information gives to help me out here. I should now be positive and a negative slope. So I still have to be above the axis, but now I need a negative slope. So I'm going to choose to put a cusp in until I get to the point 2, 0, which I'm getting from there. So I'm going to put in a cusp. Okay, and again, I didn't do a great job of making these connect. Maybe I'll actually erase this here just to make it a little bit easier to see. There we go. I've got that cusp in there. From 2 to 5, I am both negative, negative. I have a negative set of values and a negative slope. That'll suffice. And then from 5 to 10, I continue to stay negative, negative. So I'll just keep going down like that. And really, since I stopped it at 10 there, I should have a closed circle, closed circle. So this is one example of a graph that would work, that is continuous, on this interval, and fits all those characteristics.